Live streaming on YouTube. This is the Tech Ed Podcast. We are at the International Manufacturing Technology Show in Chicago, Illinois at the Smartforce Student Summit, powered by AMT, meeting fascinating people in the world of technical education, industry, and so on all week long. Today's guest is absolutely no exception. Believe it or not, there are 15,000 new technologies on offer here at IMTS. It's a place where everybody from the world of machining, the world of advanced manufacturing, the world of additive manufacturing comes to learn about the latest advancements in those technologies. And we're going to talk about one of those in particular today with a good friend of mine, a great partner of ours. His name is Juan Mario Gomez. He is the Chief Executive Officer of Xact Metal. Juan Mario, thanks for coming on.
Thank you. Thanks for having me. It's a pleasure to be here.
So I think it's been a couple years, maybe 3 years. It was a little bit pre-pandemic, I believe, that I met you for the first time.
That's
State
right.
College, Pennsylvania.
Yeah.
We were at your facility, and right away I was just absolutely blown away by the spirit of innovation. It is a startup. It has the feel of a startup, all the awesome things about a startup, all the challenges of a startup, right? So for our audience that may not be completely familiar with Xact Metal, talk about what it is that you do.
So we do metal 3D printing, particularly we do powder bed fusion metal 3D printing. As you know, that's a process where we take metal powder and then we fuse each layer with a laser. So the laser prints the shape that we want, and then we put a new layer on top, and then we do that over and over again. After that, you get a part. The parts are fully dense, they're fully usable, and it's really just treated as a forging. And after that, you'll do your normal manufacturing processes.
And as you and I were talking about this morning, some pretty considerable growth for the company the last several years, right?
Yeah,
it's really taking
It's been very exciting. We launched Xact Metal with the idea that metal 3D printing is really, really exciting. It's very, there's lots of value in metal 3D printing. We think this is one of the technologies that is the future of manufacturing. And the issue had been the prices. The technology had been very expensive. So we launched Xact Metal with the idea to make it affordable, but make it so that not only companies, small, medium companies, but also universities and schools can buy it. And it's exciting for us because that hypothesis that we used to launch the company, which was scary when we did it,
right,
it's proven to be real. People really want this technology. It's being adopted at companies, but also as universities all around the world with these lower prices. And the growth, when we see that growth be validated by customers, it's nice. Yeah.
So as we get into this, you mentioned the relationships with schools, the relationships with universities. I'm really glad you highlighted that in as much as we've got so many educators that listen to the Tech Ed Podcast, and we really are dedicated to securing the American dream for the next generation of their students.
Right.
That's what we do here
Right.
at the podcast. So lots and lots of schools are familiar with composites, with plastics, other types of 3D printing. We've been going in and out of schools for probably the last 10, 15 years and seeing those technologies. That's nothing new. If I'm a university, if I'm a technical college, if I'm even a high school, and I'm thinking about the next step in the evolution of my additive program, why should they have metal 3D printing and Xact Metal's technology on their radar?
Yeah, it's a great question. It's a kind of an easy answer. With 3D printing technologies allow you to do a lot of things. It's revolutionizing the way manufacturing is being done today in the marketplace. And without that technology, you're really not going to be a leader in the industry. We see that technology being used increasingly all throughout industry, and metal allows you to print when you really need part performance, when you need the strength of the metal, when you need the lightweightness of the metal, and you just can't get it with that of a plastic or composite. The ability to be able to do it in metal in 3D printing frees up what people can do. And we see that increasingly in big companies, and we see that technology in big companies, and we see that technology changing the game for them in how they think of manufacturing. For the universities, that is tomorrow's market. That is the Industry 4.0 idea, the digitization, the revolution that's occurring. It's happening where you can take a CAD model and print it, but now you can print it in metal, and that frees up what engineers and students can really dream up. And having that technology available not only is positioning university to be the leader of the industry of tomorrow, but it also is allowing those students to have the skill sets that they need to be in the workforce of tomorrow.
It's interesting. I was having a conversation this morning with Mike Chico, who's the president and CEO of Fanuc America, a great friend of mine, great friend of the podcast, and we were talking almost exactly the same thing. So the whole idea of I asked him what is on the horizon for the next generation of technologies, and the very first thing he talked about was digitization,
Right.
and the importance of the follow through there was the importance of students at every level of education starting to get exposure to these technologies. As you suggest, Juan Mario, more and more adoption of these technologies among industrial employers. And so if that is the type of technology that our young people, our students of all ages, are going to see when they get to industry, why not give them exposure to that while they're going through their educational pathway? That's the hypothesis, right?
It is, and frankly, I see it. I go recruit in a couple places, and the line to of students wanting to get into 3D printing. Metal is hot, but just 3D printing is also very hot.
Right.
It's a line. It's a big line. Students want to be in this technology. They want to have these skill sets. They really desire them. They're really they know that is the future.
Right.
And when you see a person that wants to do that and have access to technology to get the right skills,
right,
at a university, at a high school, at a technical school, it's really matching the two dots, and they come out of there. Those students are hot
right,
when they go into the job market, and they have those skills. For us, when metal 3D printing is typically taught theoretically, because the machines have been so expensive.
Mm-hmm.
Now with us, they're able to afford the machines, bring them in, and have not only get the skills in metal 3D printing, but actually start now doing the engineering design courses, the practicing in metal, and being innovative in metal. So it's freeing up their imagination to be able to do the skills that they want to do in the future.
Freeing up their imagination. You freed up the imagination of your company when you founded it several years ago. And as much as some of our students may be getting a lot of their information and addicted to TikTok, I'm actually addicted to LinkedIn, as you probably know. I spend a lot of time on LinkedIn, and you and I follow each other there. It is every time I'm in there, you're like on another continent in a different country. You travel the globe, it seems like, almost every week on behalf of Xact Metal. Tell me a little bit about the reaction that you're hearing, not just here in the United States, but in all the countries that you visit, spending time with people from literally across the globe.
Metal 3D printing it's demanded all over the world. Period. There's just no excuse. For us being a young company, well, you have to do what young companies do. So you have to go meet people and meet customers. You just can't do it all on social media. At some point, you want to touch the parts, you want to meet the people. And for us to go not only promote the company, but also promote the technology is very important. I was just fortunate enough last month to be named ambassador for America Makes.
Congratulations.
And they're really focusing on metal 3D printing. And the idea that we need to promote the technology, not only in the United States, but all over the world in regards to that is tomorrow's technology. And educate people that it is not out of reach, that it is tomorrow, that people are manufacturing this. It's very important. And we unfortunately have to do that in every airplane and in every location around the world.
Yeah, well, and congratulations on that appointment. We had Josh Kramer from America Makes with us yesterday, and actually, as I mentioned to you earlier, gave Xact Metal a plug on that in that discussion with him.
That's good.
And of course, he was very, very familiar with your technology and the advancements that you're making. As you and I have gotten to know each other, you had a really, really successful business career. Was it General Electric where you spent quite a bit of your career?
Yep.
Guessing when you moved on to whatever came next, this isn't something you have to do. You're doing it because you love it, right? You're not doing it to pay the bills or survive. So really, just credit to you for having this incredible passion, being willing to work as hard as you are on behalf of your company, for the benefit of students and for the benefit of manufacturers. As we're thinking about those manufacturers that are adopting this technology, are there some unique applications, Juan Mario, that you've seen that would be interesting to our audience?
Yeah, when people are trying to adapt the technology, and this is also applicable to a school, everybody says, well, I want to go put this on a rocket and fly it in the most complicated thing. And yes, that's exciting, but that's also trying to go for the fences. This technology is easily be deployable when you start slow, when you start, okay, I want to learn, I want to do the next step, and then expanding the program. And I see successful programs both at companies but also educational departments where they start with realistic expectations. Let's build it up. Let's not try to go to fences because it's very risky to do it and sometimes it fails. But when you start slowly and you build it up, the success really comes through. And I just see that. My advice to people is please just start with things that are easy to go and then the technology itself will expand once you put it in.
Are there certain types of technologies or certain applications that your particular technology lends itself to, as when we're thinking about, certainly not the only option when it comes to metal, but I know it's unique. Talk about that.
Yeah, so metal 3D printing, 3D printing is about low volume, high mixes.
Right.
And so if you want to print a lot of parts, it's better, faster process to do it with, and you can automate those even further with things like robots and stuff like that. With metal 3D printing is when you have low volume, high mixes. Typically has been a prototyping type idea, and then of course that's changing very rapidly. It's now being used truly in production environments, and what we see is that it's being used very easily in tooling, in the tooling market.
Sure.
And it's also started being used into small volume manufacturing.
Right.
When you think about it, the number one industry in today's world that's doing metal 3D printing is the dental industry. The dental industry, you can think about it. We all have different sized mouths, different sized teeth. We don't want. I don't want your teeth. You don't want my
lot
teeth.
size of one, right?
And the lot size is one. And by the way, it's built and then there's hundreds of them being printed in one printer every single day, every single moment. And that's incredible when you think about that. And that type of approach, when you're starting, okay, let's start with things that are easy, small, and start building it up when that expertise that works. And then really what I also tell people is please focus on where you're an expert on. So don't go and say, I want to do this, and I want to completely pivot what I'm trying to do. Just you have an expertise area, both as a machine shop, as an educational area, and whatever. And then take this technology and expand that expertise as a tool set. And that works really well.
My time in manufacturing, we always said, if we're going to change a variable on a production line, let's change one variable and see what happens, right? If we change 3 or 4, we don't know what changed. And it really goes to the same thing when we're talking about designing for additive or coming up with new applications. Don't come up with a whole new market and a whole new process. Let's take something we already know well, change one variable. That's maybe a different application or a different process for additive, and then see how that turns out. And it sounds like that's exactly your advice.
Yeah. It works really well. When I see that type of deployment, then you know that it's going to work. When I see educational facilities, sometimes you're fortunate enough that you get a big grant and you're able to do that. That's going for the fences. And when that happens, that's great. But most cases where I see the success is when you start slow, you start building it up, and that starts growing itself. And when that happens, it's really sustainable, because not only is it you're building in a way that's not as risky, but also you're able to grow with the people that are participating in the program. It's not like you need to kind of fill the whole room now. It's really building on itself.
So it's figuring out what we're doing well. How do we use new technology to maybe do it even better? Don't try and hit the grand slam home run. Find simple wins and adopt the technology. So
but what I will say is, please think about metal 3D printing seriously into your operation, because today when the students come and they don't have any metal experience, they're not as marketable in the marketplace. When they have metal 3D printing, it really changes the skill set of the student, and it also changes what the student can innovate around. It's completely different than when you're just trying to do plastics.
Yeah, exactly. As a student, we talk about career influences and skills when you get to industry are all influenced by your experiences and your interests when you're in middle school, high school, college.
Yeah. We actually hire students to help us in jobs. We have not only that we hire interns and co-ops, but we also have sponsor some projects, senior design classes.
Sure.
And when we find that those students, when they said metal 3D printing in the resume, they're the hottest students in the whole manufacturing. They're seeked out.
So, and as much as we have educators that are trying to figure out how to make their students as marketable as possible, right? Every single university, every single college talks about, how many of their students secured jobs in their area of interest or their area of study in the 12 months after graduation, and having experience in metal gives those students a huge leg up. And it's so important to have that talent coming out of universities as we look forward to continued innovation in the world of additive and across manufacturing. So dream with us a little bit. I know you have to give somewhat careful answers in terms of what this technology is capable of. But if we look forward 5 or 10 years, Juan Mario, what would some of those blow your mind things, applications for metal 3D printing be?
It's a tough question, and frankly, but I also give it a shot. The level of imagination that occurs when you have access to 3D printing is really unbound. We ourselves use metal 3D printing to create to have created Xact Metal. We were using the technology to make our first prototypes, to make our first designs, and we still use it. We save 5% of the BOM. The cost of our machine, 5% is saved by using metal 3D printing versus traditional manufacturing components. So we wouldn't be around if it wasn't for metal 3D printing or 3D printing technologies.
Sure.
The pace of innovation, the pace of manufacturing and deployment, and the cost savings that come with it are real, and we proof of that. And what I see really is that innovation being accelerated and being deployed quicker and quicker and quicker in all industries. As people have these technologies in plastics and metals and composites and organics, it's just going to create innovation that's at a pace of that we've never seen before. And it's not just to innovate and produce one, it's just now we're going to produce them. The idea that we're making lots of one in dental, and now we're doing in hips, and now we're doing in many cars. The idea that you have the luxury lines of car makers being all 3D printed.
Right.
It gives you an idea that we're starting to get to this idea of customization and innovation that's at the single unit level.
And in my manufacturing years, all those years running manufacturing companies, I grew up in a world. It was certainly a global supply chain, and we had global customers, we had global suppliers, and dealing with all the challenges that go along with logistics and getting products in and out of ports and managing suppliers in Asia when you're here in the United States. And it was the reality of how we had to do business, and it will continue to be the reality. But now that we've lived through the supply chain challenges of the last several years, you and I chatted about that a little bit earlier this morning, and I think things are getting better, but we still have a long way to go in that regard. The truth is that one of the things that additive offers is the ability, smaller lot sizes and really instantaneous production, right? So are you seeing part of the drive of the adoption of 3D and specifically Xact Metal's technology, folks recognizing that, there's some benefits to having a global supply chain, but there's some constraints as well, and this is a great way to work around those constraints?
Absolutely. The challenges of COVID, what happened there, really opened up that the exposure that can come from that when you're not really manufacturing at a local level. The challenge that we see also around the global economics and situations around it, the idea of being not only close to where you're producing but close to your customers is very important, and we see that very, very every day. The 3D printing is a technology that can make manufacturing in the United States continue to be a key strength of the United States. And I think, that's true of many other countries as well, because we sell products all over the world. But I really believe that without 3D printing in these Industry 4.0 technologies you see at shows like that is tomorrow's competitive advantage, and that's happening now back increasingly more in the United States.
Exactly, and we're seeing it not just in manufacturing, but across the supply chain in a lot of different industries, folks understanding what a challenge we had in the last 2.5 years and how important it is to be able to produce products as close to the point of consumption as possible, at least, and be able to do it economically, and certainly 3D and additive is a huge part of that. You mentioned all the different technologies that are here at the International Manufacturing Technology Show in Chicago, 15,000 of them to be exact. So I was reading up on the show a little bit last weekend, and that's what they were advertising, 15,000 different new technologies that we can see at IMTS. If folks have never been here, 2,000 booths. It really is like walking through a large city of technology, and it's just every year it blows my mind, every 2 years that we're here, and just the advancements in those technologies. Advancements in technology, you're certainly no stranger to that at Xact Metal. The XM300G, your latest product that was recently introduced here in September, and you're talking all about it here at IMTS. So tell our audience about that technology, what prompted the R&D and the development, and where do you see the applications?
Thank you. That's a great question. We started Xact Metal again with the idea of making metal 3D printing more affordable, and we started with a small printer. That it's an easy way to start. We talked about building it up and building it in little steps. That's important. So let's start with the easy step. We started with a small printer. When we started with a printer that was on an XY gantry system and moved the laser beam around that way. And what we found very quickly is that people really wanted our technology in terms of price, but they also needed the speed. So we ended up pivoting, and we introduced a more traditional approach on how to move the laser beam around. That's faster, and it just allows us to now not only have the price point, but allows us to have the speed that people need. But what we found is manufacturing people, of course, are driven by speed. And so the faster you can build a part, the more you can put to the machine. And that's very evident for us in metal 3D printing. What we also found is that people want to put more parts on the machine, or they also want to put larger parts. So we needed to have a larger printer that still gave the speed. So we used the platform of what we call the XM200G, which is a smaller printer. We used that industrial single laser and multi-laser platform to be able to now have a quad laser system, one single, double, or quad laser system with multiple lasers operating the number of lasers dictates the speed of the machine.
Okay.
And also the power of the laser dictates the speed of the machine. So the more power we have, the faster we can go. The number of lasers that we can do, we have more brush strokes painting the part or building up the part.
Sure.
And so now we can actually build a part that's now a relatively large size. It's roughly a cubic foot, a little larger than a cubic foot.
Right.
So, and many, many big parts fit in there, or if not, many little parts fit in there, and it gives the customer the flexibility for that. So we launched the XM300G with this new platform. We're very, very excited about that because we think with these two printers, we'll cover about 80% of all units that will be needed in 3D printing in powder bed. And we're very, very excited to be able to do that because when we see, this happens every day. We come to a show like this, and people look at a metal 3D printing, both industry people and students, and they say, wow, this is super cool, I'd like to do that. And they say, well, I can never afford that machine. And then we say, well, this is the price of the machine. And it's like, oh, let's talk about it because I can kind of find that money in my university, my high school, in my company, and they step in.
Sure.
And then their eyes open up and they start talking to us, and that's exciting. And now we're doing that with a larger printer.
Right. Well, and you think about, I mean, being able to print a part that's 12 inches by 12 inches by 12 inches, right? I mean, in cubic foot. I mean, that's a huge part, and it's gonna. I've got to believe that in turn on the industrial side gives you access to even more applications. And when we think about the exponential economy and products doubling in price performance every 12 to 18 months, and the more different applications we could have for a given technology, obviously that's going to drive growth. So you're pretty optimistic, I would think, about the future from an economic standpoint.
We're very, very. I think both printers are hitting the sweet spot of what our customers want, and then the fact that we do it with a printer that if you are printing a metal part, it better be good quality. Otherwise, just print it in plastics, quote unquote. And because it has to meet the performance demands of that part. If you're trying to do something that's going to go in somebody's heart, or if you're trying to put it in a car, put it in an airplane or a rocket, it better do its job. Otherwise,
it's a mission life critical part.
Right. Or even if you put it at the end of the robot and the thing breaks.
Right.
So you just cannot afford the metal parts to not be metal quality. So our printer does that, but does it at a lower cost.
So you talked about the reaction from the universities, the educators. They love the price point. They love the application. How about the industrial employers? What are they saying?
Oh, the same. It's kind of the same. They both have the same need in regards to they want the technology, couldn't afford it. So now what we really, it's exciting for me is that we are doing two things. We are allowing small, medium enterprises to afford the technology to be able to bring it in. There's so many small, medium enterprises, machine shops in the United States that have lathes, have CNCs, and they should think of the metal 3D printer as adjacent to another tool that they have in the tool set to be able to do the job. And we're seeing that in small, medium companies. So now we have small, medium companies that you've never heard in your life, but are very competitive and do a very good job in the marketplace today in their industry. And this is a technology that allows them to step up with the level of competitiveness they can do to not only offer more products, but also be more effective at doing so. And we see that all over the world. The other thing that we're seeing is that metal 3D printing has been very exclusive. It has been very expensive in the past. And so now with our pricing points, not only are we seeing small, medium enterprises afford the technology, we're also seeing the deployment of the technology across large organizations so that the machine is next to the engineer, next to the manufacturing facility, next to a service center at a large corporation, because now you don't have a central lab. You're able to diffuse it. I like to say this: the only engineer that likes the central lab is the engineer at the central lab.
Exactly.
And that's but that's a little joke to make the point that in reality, to be effective and efficient, and you need to put the tool next to the person.
Absolutely. Yeah, it really becomes the democratization of metal 3D printing.
And then it's going to continue to expand. We have a website, and there's a couple of things that I'm really proud. I'm very proud of the brand names that we all recognize, because of course that's easy to sell, but more proud of names that you've never heard.
Isn't that the
there's
truth?
A company called Corey Manufacturing in Central Pennsylvania.
Okay.
They do a great job. They're very competitive in what they do. They have a 3D printer. And without our pricing points, they were never able to do so.
Sure.
We have and by the way, this is the same story about distribution as well as small, medium. It also carries to universities. We now have large universities buying the printers, but distributing them within the organizations. But then we also now have small, medium universities buying the printers. One of the there's a small community college in Ohio that has bought a printer. We just love having their logo on our website.
Sure.
Because it's just a community college that's bought a printer to train the next generation of technicians.
Right.
And yes, we need engineers, but we also need technicians. And I'm very proud of that logo.
Yeah, you should be proud of that. The work that you're doing in education, and we've gotten to know your team, not just you, but other members of your team, and just phenomenal people, and doing really, really important work. I could talk about this all day. I know you're on a limited schedule here, Juan Mario. A couple more questions for you.
Yeah.
We've been all over IMTS. We're 4 days into the show, and that. It was a little tougher earlier in the week when we were asking people, what's the best thing you've seen? And they're like, well, it's a Tech Ed podcast. It's the first thing I did. But now, now you've had the opportunity to walk all over the show and see other technologies outside of the great things that Xact Metal is doing. What have you seen that's really intriguing?
My main belief is more that the digital technologies that are happening, the idea of the digital manufacturing line is real. That you come around and you see the speed of innovation being allowed to be happen because of this digital technology. The fact that we can not only scan a person now a part, we can print the person, we can print the part, we can then print we can have a model of that person, a digital twin. The fact that we can then adapt, modify it at the individual level. That's to me incredible, and that journey for me is just but starting and will only but accelerate. And I see that, just look at robot makers and look at us and look at all the software companies. We're all trying to make that happen. And it's happening faster and faster and faster to the point that we can make customization and innovation at the individual point of a person. That's, to me, the incredible part. I don't have a specific example. I just know that this Industry 4.0 technology that's happening today is the technology of tomorrow and must be it's being adapted by industry and must be adapted also by the educational sector.
Yeah, absolutely, the technology of tomorrow. And I think back to 4 years ago, 6 years ago, when we were talking about digital twin technology, being able to innovate on the digital twin as opposed to on the hard asset. And it was still, people were doing it, but it was out there, and now it kind of feels like that technology's come of age. People are recognizing, yes, you really can test process, you can develop processes in manufacturing operations and so on, using automation, using robotics, using Industry 4.0, using additive, and do it all digitally and make all your mistakes, or at least many of them digitally, before you ever worry about trying to build the physical manifestation of that operation. And that technology's here, isn't it?
I've been around a little bit, not as young as I wish I was,
yeah,
but
you and me both.
I go to the dentist's office today, and when we were used to go to the dentist's office, oh my God, put an X-ray here. Now they have a CT scan of your mouth. They print exactly your tooth. They mill it right on the spot. If not, you'll get the part 2 seconds. And it'll fit perfectly. They'll tailor your retainer to your mouth.
Right.
That's happening in industry today, not just in the dental marketplace. It's so exciting to see that, because that's revolutionizing not only the speed of innovation, but also it's what's making industries in North America and the United States more competitive.
Exactly. One last question in the 1 minute that we have left, as our producer is letting us know that we're running short on time. One of the questions we love asking our guests here on the Tech Ed podcast is, if you could give a piece of advice to a 15-year-old, 16-year-old kid as they're considering their future, that high school sophomore, as they're working their way through what comes next, what is that piece of advice for that individual?
Getting the 2 points. One is go for your dreams. Don't be afraid to fail. When you're our age, if you fail, it's a big problem, because you don't have time to recuperate. When you're young, go for that dream. Fail. You're going to learn so much by failing that most likely you're going to be successful.
Right.
Even if you fail, you'll be successful, but most likely you are going to be successful if you get a shot. My advice to people is, please go for your dream. Go fail. You'll find so many things from that journey that it's going to open more things for you. And just go for that. Don't get stuck on that. Do not get stuck on something you don't want. Go for your dream.
Don't be afraid to fail. Go for your dream. You went for your dream. You're having tremendous success, Juan Mario. It's been just a wonderful time, not just with you here today, but watching the evolution of your company. Best of luck in the future.